Hi, HRED 7050 students. This is Dr. Gleesman here. Just to review some of the readings I've assigned tonight, go over some major points, but also discuss design thinking. Really, what is it? Why is it important? You looked at the user experience principles earlier last week. And now we're going to look at design thinking, and this process is going to drive our project really for the next 4 weeks while you work through the middle of this course. So I briefly mentioned in my introduction video, I have a background in math education, instructional design, but my PhD is in learning design and technology. And I did a lot of really research. It's called the design-based research, but I did a lot of research around designing learning environments, specifically learning environments where children were learning to program. And I looked at the design decisions that I've made in those environments, and I did some research around really what makes an efficient learning environment, what promotes deeper cognitive thinking around programming, and that's guided my research agenda. During the early stages of my career, and now even today, I still feel as though I am a designer at heart. And so when we look at design thinking, I want to pull out some of the quotes that I enjoyed from the reading. There were two readings that are really seminal pieces. So they're kind of foundational design thinking research throughout the early 2000s. I think 2002 was Edelson's, and then there was a Razzouk and Shute piece from 2012 that came out in, I believe, ETR&D or AERA. And that really talked about design thinking and trying to situate it within really education, but also as its own methodology and its own really context and discipline. So, what is design essentially? And I really like this quote that design is a sequence of decisions made to balance goals and constraints. In every decision we make, it be an administrative decision or even a life decision that we have frequently, we want to balance what are our goals, but we also have constraints to consider as we make some problem solving or design decisions. And what really makes an expert designer? That's what I ask myself frequently. My brother's fiance is a designer, a fashion designer, and I talk to her pretty frequently about her process of uh, really sketching out prototypes for different lines that she's working on. She works for Express, and I like to look into her process as she's designing something brand new, something that maybe hasn't been seen before, or something that's interesting to her clients, which are the folks shopping in the Express store, but also that satisfy the associate and lead designers on projects. And what I find is that even if I compare my process of designing a learning environment with hers, is that I'm often solution focused when I'm making my best designs and my best decisions, rather than looking at a problem and trying to be problem focused when I'm designing these environments. This allows me to really identify a problem and propose a solution quickly, but I'm always looking at that actual solution and how that impacts my user. And she does the same thing when she's designing different fashion lines or maybe a different piece of clothing for that specific maybe year or new line. And then the other quote I really enjoy that I pulled out from another piece is designers should be able to assess the conditions of a given situation and quickly adjust their actions depending on the current set of needs. We're going to talk about empathy design or human centered design. And I think that's what makes a great designer, this flexibility to understand the context and conditions they work in, and eventually being able to make some quick adjustments and decisions with that. I like the idea that when we help either our students or our colleagues to think like designers, we actually are helping them prepare for these difficult situations that they might come across in their careers, and then make quick adjustments and solve complex problems. That's kind of what we're hoping to do. So a lot of people say promote critical thinking. I also think we should promote design thinking as well. Here is a list from one of the readings This is actually, I believe it's from the, it should be from the, uh, possibly the Edelson reading, I believe, that pulls out just some characteristics of design thinkers and how we promote different types of thinking uh, when we're thinking in this manner. And we're doing design, which sounds kind of weird to say, but we are doing design and designing. But I like that last one specifically. You can read through this, and hopefully you have already. But avoiding the necessity of choice. Designers search for competing alternatives before moving to choice making or decision making. They try to find ways to come up with new configurations, and then this process leads to a solution that avoids decisions and combines the best possible choices. And this is sometimes known as like finding the middle ground, finding the balance between functionality and what your maybe technology or decisions limit those constraints and what is best for the user. And I have a really great example of this that I want to share. Magic plus engineering. You never thought these would go together, but seeing what your constraints are, understanding your context, and making some difficult decisions is what is demonstrated in this video. And I really like the design they came up with. Just to give you some background, this is a magician that also was training to be an engineer and was working with a design studio. We'll talk about Stanford's design studio. This was a different design studio. And they were asked by Samsung to design a product that would help some of the older generation use a phone. And we know possibly with older generations and using technology, it's not always as smooth, but leaning on some of their strengths, so knowing their context, being able to make some adjustments, but not necessarily looking at the exact problem, but focusing on the solution is how this process went in my analysis. So check it out. I will minimize myself and we will watch a few minutes of this video. I'm not watching the whole thing, but just a portion of it.
This is actually one of our first projects here at Special Projects, and our client Samsung asked us to try and find a way of making smartphones easier to use for people of all ages. And rather than designing a new phone, we actually tried to change the way that you learn how to use it. And we transformed the packaging into these two hardbound books. Now, the first thing you see when you open this one is actually the SIM card. And it tells you, this is your SIM card, the heart and soul of your phone. You actually see the phone inside the book. So you slide the SIM in. Now, normally this is the bit where people want to throw the phone across the room because it's so frustrating. But by doing it in this way, we made the whole experience really magical, and people were actually giggling when they were setting up the phone. The next book is actually the main manual. You put the phone actually in the manual. All of the instructions point exactly to where you have to press the phone. So we took something that was really complex and quite messy, looking at a little manual here, looking at the phone, and we put it all together in one place. It created a really effective way of learning how to use your phone. By taking this sort of step-by-step revelation and wrapping it up into this sort of transformed book, we've made this experience feel very magical. Welcome to our studio. So this is another project that we engineered using cards. So the problem we were asked to solve was to try and find a way of encouraging people to explore their phone, because a lot of people just don't really know how much their phone can do. And we thought that cards were a perfect mental model because they don't really need explaining. Everyone knows how to explore a pack of cards. So what we did was actually make a card for every function of the phone. Take a photo, call someone, send a message. When you want to actually perform one of these functions, like take a photo, you just tap the card on the phone and it immediately jumps to that function. On the back of the card, it actually explains how to get to that function without the card itself. Every card has actually got a little chip inside it, and the phone has got a sensor which is able to sense it. So we didn't need to add any kind of crazy technology to the phone. We were using something that was already there. I think this project for me is a really nice example of combining engineering and magic. On the one side, you've got the technology.
So what I love about this, and he goes into say you have the technology, but it's really about the ways of thinking, which are interesting. And so and sometimes so simplistic. I think the best designs are often very simplistic. He mentioned that he didn't have to add a technology or develop any really innovative idea to make that learning process feel more comfortable for the user. And that's something that I think we aim to do when we solve problems every day, regardless of the industry or context that we're working in. Uh, I also really love that there's an empathy design model where it's really focusing on how the user feels while they're going through a process. And so, as we move forward, we'll talk more about empathy design, but I think this is a great depiction of what an expert designer can do. And I think we all have that really in us. And it's just how do we pull out that way of thinking, especially when we're working with maybe a diverse demographic or different folks from different backgrounds. We have to have that empathy and try to design a work environment and make some administrative decisions, or think about how we're going to implement probably a new uh, goal or a new process into our department. We have to think about this design and how we can actually empathize with our users or our colleagues. Moving forward, what do we do when we actually engage with design? Remember, we don't want to just focus on decisions, even though that is at the core. Before we make any of those decisions, we want to try to focus on designing solutions, not just focusing on the problem. But it's a balance between problem analysis when we're gauging. So sometimes, like a needs assessment, you could think about design procedures. So when we are engaging with design, we're specifying a process, we're thinking about the people, we're addressing needs, we're thinking about implementation, development, revision, evaluation, and refinement. And when we design solutions, we want to often design those solutions just as a result of a problem analysis. So I talked about the Stanford D School design, which has empathy really at the beginning. But again, this is all iterative. It's not necessarily linear, but you can empathize with your users, define maybe your problem, do some problem analysis, ideate, come up with some of those solutions. We actually are going to prototype a solution this semester, and then you test it and you refine it. Here's some other instructional design models. What you'll notice is that in education, we love models, especially in instructional design. We love models. And so this is a ADDIE model, which is a fairly famous instructional design model. You can see a lot of similar steps here, where evaluate is really that problem analysis section or the empathy part, but there maybe be a lack of empathy as a specific step in this model. Same with the Dick and Carey model. This is really about identifying instructional goals and then writing performance objectives. You can see this oftentimes. Something similar to a Dick and Carey model that you see is often evaluative, uh, like faculty evaluations or professional evaluations, often where you identify an overarching goal for a department, write your own performance objectives based on some criterion, and then work through this. It's obviously an instructional design, but the evaluation is very similar in this way. Um, but you want to kind of work through a systematic model. This is another model just to go through about rapid prototyping, where you have like a task and it's broken into phases. Again, setting objectives, constructing a prototype, utilizing it, doing research, and then installing an actual system or an actual process and maintaining that. And as time goes, all of these processes, they happen staggered, but they also happen at the same time, so it's more cyclical. You might have heard of backwards design or a more spiral design when you're designing perhaps a curriculum. This could be a similar process here, that where you identify objectives again and then start with a preliminary design, really a workflow or flow chart. But as you work through, you're not just designing and seeing how it works, but you're designing, developing, and then you'll see a finished product and evaluate it at that point. So there's a difference between the act of designing and doing design-based research. And I mentioned that at the beginning, but DBR, we'll talk a little bit about this, but what DBR helps you do is make high-level conjectures. And we're actually going to do that. We're going to do it more so for the design process. But if you're interested in DBR as a methodology for your PhD studies, I suggest you look into it and reach out to me. I have some other pieces of literature that you can read, or if you're interested in running a study by me, please let me know. But DBR is a really a methodological approach that aligns with research methods of some of the more technical fields of engineering and physics, but it's all focused around designing products with a purpose. And you're really interested in the process that a learner or a user goes through, not just the more positivist view that, hey, let's say a iPad increases reading comprehension because it increases reading comprehension. The idea is you're more interested in why does that happen and what is the influence a technology would have as they are on the reader. And DBR is more interested in even how that learning environment is designed with a technology per se. But it's really about the process of designing an environment. And that's what DBR is really about at its core. There's a resource at the bottom of that slide, which really breaks down these two examples. The one on the right, example B, is a contextualized version of A, where you actually design, test, evaluate, and reflect. You'll see how a lot of these have similar themes, right? They're somewhat cyclical, iterative in a sense, and there's always this reflection, evaluate, test, and design in a lot of these models. In DBR, you often start out with this word hunch, which Edelson mentions on page 109. And I really like that word hunch because I think a lot of us go through life and we have either an idea, or when we're actually presented with a problem, we have a hunch of like what works and why it works the way it does. And we all have these hunches in life. And this is a clue that abductive reasoning is needed in design-based research when we're designing a solution, right? And that's comparatively to deductive and inductive reasoning. And I put this here. So abductive reasoning is you have some incomplete observations. We've all experienced some things, but we haven't experienced all, and we have our best predictions, which may be true. That deductive reasoning is usually we have a general rule, and then we make specific conclusions based off of that general rule that has been placed. And it is a rule, so it's there. And that's usually always true. That inductive reasoning is we make specific observations. So we have maybe a complete observation of something, and then we make a general conclusion, which may be true. And you can see this deductive, inductive, abductive example below, which I like, where you can see that, work through this, and you can see that Socrates is mortal. That's that deductive. It can be say that it is always true because he is a man and men are mortal. And that inductive, you can say that Socrates is a man, Socrates is mortal. But does that mean all men are mortal? That's not always true. That is sometimes true, right? In the inductive, or maybe it can never be true. It's just a general conclusion based off of that induction. And then that abduction is all men are mortal, Socrates is mortal, and Socrates is a man. Is that always true? In this case, we can say that based on some of these, we're using abductive reasoning. But you can see the difference between this. And in DBR, that abductive reasoning is often why you can keep being iterative. You can keep making different cases and understanding it further, just because you don't always you start with that hunch, you start with those incomplete observations and try to make those best predictions and use research to continue to understand it. So with design research, you're supposed to be thinking about generalizable theories. And so there's theories which you'll hear about, there's design frameworks and design methodologies. A design theory, let's say, is more of a generalizable type claim of some portion of a problem analysis. So a theory about the world, but not necessarily the design. Where you get into a design framework, you have a generalized design solution. And so it's more prescriptive in nature, where you can say, hey, I've designed this product around this framework and it helps me achieve these particular goals. When a design methodology is a more general design procedure and it provides guidelines for the process rather than the product. So you can see that with a design methodology, perhaps around a classroom. It will work in a math classroom, a science classroom. You could also see this type of design methodology as working with a group of people. There's a way to kind of facilitate conversations, let's say, in our work environment, and here are some methodologies to do that. So a couple other things I enjoy is the goal of ordinary design is to create a successful design product. But when you're looking at that design research, it retains that same goal, but it adds an additional one. And that goal is to develop useful generalizable theories. And so if you're interested in DBR and applying this to maybe some of your work, please let me know and we can talk further. But I put a little diagram together where that decisions, yes, they're at the beginning or at their middle of the intersection, but you want to, before you make any decisions, design decisions, you want to focus on those three components first, and you really want to consider designing solutions, not just making design decisions. And with the goal in DBR is to have useful generalizable theories. This is a way to distinguish design and design research. Again, you want useful results that are just beyond the context that you're working with, but they help other designers in other fields similar to that. Engineering and magic, why would they go together? But that idea of intrigue, working through step by step, is similar to how a magic trick would be constructed as well. But you want to have some research driven decisions, which we'll talk about later, some systematic documentation. You want to actually have a design process or model that you're following, formative evaluation. You want to evaluate and have some iterative processy that gives you some really formative feedback throughout the design process, and then some generalization that expands beyond that context. So just based on the readings, hopefully you enjoyed them. They are seminal pieces, so these are some really foundational, popular pieces for design thinkers. And just summarize your thoughts. I put this in video form for a PowerPoint, but summarize your thoughts in maybe 4 to 5 sentences or bullet points on this Google form, and I look forward to reading your feedback. And then I will continue on with the slides in another video, and that will be more about empathy design and human-centered design. So thanks for doing the readings, and I hope you enjoyed them, and I'll talk to you soon.